So in this video, I'm going to go over the Unit 12 test review. So first of all, it says use the graph to find the equation and find the characteristics. The first thing we need to do is look at where is the vertex, which is right here. So that's going to be 2, 4. So that's our first thing here, is our vertex is 2, 4. Then when we look at the slope of this equation, what we want to do is we want to look at rise over run. So I'm going to start here at this point. I'm going to go up 1 and over 1, 2. So that means our slope is going to be 1/2. And notice this graph opens down. So when we're talking through these points, recall that this is equal to h comma k, and that this is going to be equal to a. Now in this case, it opens down, so our a is actually going to be negative 1/2. Okay? So now when we do our equation, it's going to be a x minus h plus k. So what we're going to do now is substitute these values in. So that's going to be negative 1/2 x minus 2 plus 4. So also what we want to talk about now are our transformations. So if you recall, if it opens down, then that is a reflection across the x-axis. So when a is negative, that's a reflection across the x-axis or over the x-axis. Okay, and then when we talk about the 1/2, that's going to be a vertical compression or vertical shrink by 1/2. And then the 2 means it's moving to right. And the 4 means it's moving 4 up. Because remember, h is left, right, and k is up and down. Okay, so then our intercepts on this particular graph, we can actually see them here and here. So those are our intercepts, negative 6, 0, and 10, 0. And I want to talk to you all about how to solve these in case you can't see them. So when we're solving them and we can't see them, we say 0 equals our equation, which is negative 1/2 absolute value of x minus 2 plus 4. So we would add 4 to both sides here. And that would give us 4 is equal to negative 1/2 absolute value of x minus 2. And to get rid of that negative 1/2, we would multiply both times negative 2, which is the reciprocal of negative 1/2. So that's going to give us, wait a minute, guys, sorry, let me go back. This should be minus 4. Love it when I catch my errors, right? So this should have been a minus 4. And some of you probably caught that while I was doing it. So this is going to now be 8, because it's negative 4 times negative 2. And that's equal to the absolute value of x minus 2. And hopefully you remember that we have to solve for both a positive 8 and a negative 8. So I'm going to do that here. So I'm going to add 2 to both sides here. That's going to give me negative 6 equals x, which is what we had right there. And add 2 here. That's going to give me 10 equals x here, which is what we had there. And remember that these are also our zeros, so we can say x equals negative 6 and x equals 10. Now we have one more zero that we want to talk about here, and it is this one right here. Or not zero, sorry, but intercept, and this is the y-intercept. So this one is going to be 0, 3. And the way we solve for this one is we put 0 in for x and solve for y. So we would say y equals negative 1/2 absolute value of 0 minus 2 plus 4. So if we take the if we do 0 minus 2, that would be, let me scroll this up a little bit so I have a little more room to show y'all. This would be negative 1/2 absolute value of negative 2 times that plus 4. So that would be negative 1/2 times 2, because the absolute value of negative 2 is 2, plus 4. So half of 2 is 1. And if we multiply a negative times a positive, we get a negative. So this would be negative 1 plus 4, which is equal to 3, which again was the number we got right there. Okay. Now, let's talk about our intervals of increase and decrease. I'm going to erase all this. You guys can just scroll back on the video if you need to see it again, okay? So on this one, we're going to talk about our intervals of increase and decrease. So when I jump on my graph over here at negative infinity, is it going up right now or down? Yes, it's going up. And it's going up till we get to this point. Do you see that? So it's increasing from negative infinity to 2, which was the value right here, right? And then when we get on the graph here and we go this way, it's decreasing now, you should see. And so it's decreasing from where? From 2 on to infinity. Remember, these are x values that we're talking about here, okay? Now we're going to talk about our piecewise function, okay? So when we start talking about our piecewise function, I'm going to do it up here because it's close to the graph. So we want to again get our slope, which we should be able to see right here, is 1/2, right? So if we're talking about this part of the line, then it's a positive slope because it rises from left to right. So it's going to be 1/2 x, right? And where is the y-intercept? It's right there. So that's +3. And this is true if x is, and we'll just say less than. If this arrow is pointing this way, then this arrow is going to be pointed left, okay? And then it's less than what value? What value is right here, guys? 2, yep. All right, now let's talk about the other side. So this is actually falling from left to right. Now the slope is going to be the same, 1/2, which we had up here when we were doing it. Remember when we talked about this 1/2 right here? So then this is going to be 1/2 x, okay? Now to find this y-intercept, we can go up 1 again and over 1, 2. So do you notice that point right there? Yes, so that's +5. And this one is true if x is what? Greater than or equal to our 2. So that's our piecewise function. I'm going to write it down here. So it's going to be f of x equals, and here we go. Let's see if I can do this. I can't do this today. So this is 1/2 x plus 3 if x is less than 2. Now this could be less than equal to, and the other one could be greater than, and we're going to do that on the next one. So this was, this was negative here, right? Because it was falling from left to right. And this one's going to be negative 1/2 x plus 5 if x is greater than equal to 2. Okay? Now we're going to do another one just for practice, okay? So here's our next one. So once again, we're going to find our vertex, which is -2, -5. And then we're going to talk about our slope again. So we're going to go up 1, 2, 3, 4, 5 over 1. So that's 5 over 1, which is 5. Now we're going to put it back in that equation. A x minus a -2 would be +2. And then -5. So there's our equation. Transformations. This one doesn't open down, so it's not going to have a reflection over the x-axis. But it is going to be a vertical, this time stretch, by a factor of 5. And then it moved left 2 and down 5. And remember, that's h and k up there with our vertex. So now here again, we've got our intercepts. We can see them on the graph. So we've got one at -3, 0, and we've got one at -1, 0. It's kind of nice when you can see them from the graph. Now you can use the formula to prove that. Remember, our zeros are our x-intercept, so these are going to be, this is going to be x equals -3 and x equals -1. And on the test, make sure you say x equals, okay? And then we've got this other one up here, which is at 5. So this one's going to be 0, 5. That's our y-intercept, right? Okay, so now we're going to talk about our intervals again. So I'm going to jump on my graph over here at -infinity. I'm coming, yes, down. So that's decreasing. And it's decreasing till -2, right? So this one's going from -infinity to -2. And then we pick back up here and it's increasing, right? And it's going on to infinity. So remember, this was -2 here, right? So This one's going to be increasing from -2 on to infinity. Then we want to talk about our piecewise function again, okay? So with our piecewise function, again, we're going to look at these equations here. So we're going to look at this one, and it goes to here, right? So again, we should know what our slope is right here. So this one again is falling. Do y'all notice that? So this is going to be -5x. And if we want to figure out where, we can count 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. That would get us at -15. Now, if I didn't feel confident about that count that I just did using the slope, then I could use y equals mx plus b to solve for b, okay? So to do that, I could pull this point right here. So that would mean that would be 0 equals, our slope was -5, our x was -3 plus b, right? So that's going to be 0 equals 15 plus b. So b would have been equal to -15, which is exactly what we got. Now this is true if what? X is, now this time I'm just going to say less than equal to. Again, doesn't matter which one we do with the equal, but only one can have the equal. And what was our value right here? Yes, -2. All right, now let's do this other one here. This one right here, okay? So once again, this is going to be 5x because it's a positive slope. We can see the intercept right here, so that's +5, and this one is if x was greater than -2. Again, it doesn't matter which one of these has the equal sign under it, just make sure that both of them don't. So when we write this piecewise function, it's going to be f of x equals, and I'm going to say -5x minus 15 if x is less than or equal to -2, and then 5x plus 5 if x is greater than -2. All right, let's go on to the next one. So this one says evaluate the piecewise function for x equals 3, 1, 9, and -2. So when we do this one, we want to look at f of 3. That's when we put 3 in for x. So first thing we have to do is look at these if statements. So which one of these if statements would be when x is equal to 3? It would be the bottom one, the third one. So that just means I put a 2 here because that's the answer. So if I have an x value and I can plug it into that equation, then that's what I'm going to do. So then our second one is going to be f of 1. So which one of these equations does 1 fit in the if statement? Yes, it would be this one, right? Because 1 is between -2 and 3. So on this one, we're going to put in the equation on the left. So that's going to be 1/3 times 1 plus 1. So that's going to equal 1 1/3 or 4/3. Okay? Our next one is going to be f of 9. So on this one, again, we're looking at these three the if statements. Obviously, 9 is not less than or equal to -2. It's not between -2 and 3, but it is greater than 3. So this one is also going to be 2. Our final one is going to be f of -2. So once again, we're trying to figure out which one of the statements. So is -2 equal to -2? Yes, it is. It's less than or equal to. So it's going to be our first one. So on this one, we're going to say -2 plus 2 squared plus 1. So this is going to be -2 plus 2 is 0, right? 0 squared is still 0. So that is going to be equal to 1. So here again, you're going to look at these if statements to determine which of the equations you're going to plug the number into. So this one says write the piecewise function for the graph. So what we're going to do with these is we're going to kind of work through them a piece at a time. So the first one we're going to work through is this one right here. So what we want to do first is write f of x equals, and we're going to write our piecewise statement here, okay? Move this down, whoops, to there. All right, so notice the slope here. So that's what we're going to count first. We're going to go up. I'm going to take this point right here and go up 1, 2, and over 1. So that's 2 over 1, which is 2. So that's 2. And is this rising or falling? It's rising. So this is going to be a positive slope, 2x. Now, if we keep using this slope over and over again, then we can get the y-intercept. So I'm going to go up 1, 2, and over 1, go up 1, 2, and over 1, go up 1, 2, and over 1, go up 1, 2, and over 1. Notice it's at 7. So this is going to be at 7. Now, when is this statement true? If x is, now notice that the arrow's pointing to the left down here, y'all. Okay, so that means this arrow is going to be pointing to the left. Then I just have to determine whether it's going to have an equal sign under it or not. This one's not because it's an open dot. And then what is this value right here of x? It's -4. Yep. Okay, so now let's move on to the next part right here. Okay, so again, we want to look at the slope. So this one's going 1, 2 to the right and 1 down. Right? So rise over run. So let's just go 1 down, 1, 2 to the left or to the right. So that's going to be a negative slope, right? So that's going to be -1 over 2x. And here again, we can go down 1 and over 2 and notice we're at the -3. So that's our equation. We just use the slope to get to the y-axis again. And this one's going to be true if, and this is going to have a between, right? So x is going to be between what? -4 and -2, right? So then we're just looking at the sign. So notice that the dot over here on the left at -4 is open dot, right? So that's going to be a less than. And the one on the right here at -2 is going to be less than equal to, because it's a closed dot. Actually, there's no dot there at all, okay? Then we're going to move on to this graph right here, from here to there, okay? So this is again up 1 over 2. The slope is 1/2. This is a positive 1/2 x. And we can actually see where this one intercepts the axis, right? It intercepts it right there. So this is going to be -1. And this is if, again, and we want to look at from here to there, the x values, right? So that's going to be -2. And the one on the right is going to be 4. X is going to be in the middle. And these are both going to be less than equal to because we don't have any open dots. Then our final one is going to be this one right here, from here over, right? So what is the y value there? It's 1, right? So this is 1, and it's 1 if, again, x is, what was this value right here? It's going to be x is greater than and equal to 4. So again, here's a hint for you guys. This symbol, notice that this is kind of pointing to the left, and this symbol right here is pointing towards the right. So when you have lines like that, then your arrows should be pointing in the same direction when you're talking about your symbols, okay? This one's a step function, okay? So on this one, we're going to do f of x equals, okay? So on this first one, we're at -4, and it's if what? Notice these points right here, -7 and -3. So we're at -7 over here and -3 there, putting our x in the middle. And this symbol here is an open, so we're going to just put an arrow like that. This one's closed, so we're going to put it with the equal sign, okay? Our next one up here, this one right here, okay? So again, this is going to be at 1. So that one's at 1 if what? So again, we're looking at this value here and this value here. Those are our left and our right. So that's -3. Again, open, so it's an x. Less than, sorry. And then the one on the right is going to be closed. So it's going to be less than equal to. And that's it. Is that 6? Yeah, 6. Okay. Then our third one up here, this one. Okay. So this one's at 6. If what? Again, look at your value here. 6 to 10, right? So we got 6 here. Again, open circle on the left. So that's where our x is. And then this is going to be less than equal to 10 because it's a closed circle. Okay. So then the other part it says up here is to evaluate for these. So what we want to do is, there's a couple ways to do this. We could put them into the equations, or we can put them into the graph. So let's look at the graph for this one, okay? So when I do this, it says for f of -3. Okay, so I want to look at when this is -3. So I could go up to that open dot or down to the closed dot, and I'm always going to choose the closed dot. So the answer here is going to be -4. Okay. Then we've got when f is 6. So that's right here, okay? So once again, notice we have a closed dot here and an open dot here. So we're always going to choose the closed dot as our answer. So this is going to be, again, we're looking at the value right here, so that's 1. So number 6 has to do with sequences and series, okay? So we have in the sequence 256, 128, and 64 that it wants us to find the common ratio. So remember, when we do this, we're going to do our second term, and we're going to divide it by our first term, okay? So that means we're going to take 128 and divide it by 256, and that equals 1/2. So that's our ratio. When we use the recursive formula, we're basically going to multiply that ratio times the numbers. So to get our next number, we're going to do 64 times 1/2, which would have been 32. And then we're going to multiply that times 1/2, which would be 16. And they're going to multiply that times 1/2, and that's going to be 8. So our next 3 terms are 32, 16, and 8. That's what the recursive formula is used for, okay? Now with our explicit formula, I'm going to go ahead and write the formula first for you guys. So with our explicit formula, when we're trying to find the 8th term, it's going to be a to the 8th, and then we're going to use our first term, and we're going to multiply that times the ratio to the n minus 1 power, okay? So here, n is going to be the 8, okay? So when we do this, our first term was 256. We're going to multiply that times our ratio, which was 1/2, and we're going to take that to the 8 minus 1 power, so that's going to be 256 times 1/2 to the 7th power. Now when I do this in the calculator, you can do it 256 times 1/2 to the 7th power. It'll do it right if we do it this way. But I often do 1/2 to the 7th power first and then multiply it times 256. Either way, the answer is going to be 2. So the 8th term is 2. Okay? This was the formula right here. Well, actually, this is the formula. Okay? So if it asks you for the formula, that's what you're really going to write. Okay? Then it says the sum of the first 10 terms. So that would be the sum of the 10 terms, the first 10 terms. Okay? So then we're going to put our A1 here again, and we're going to multiply that times 1 minus r to the n power divided by 1 minus r. So let's go ahead and populate this formula. So this is again going to be 256 times 1 minus our 1/2, this time to our 10th power, okay, divided by 1 minus 1/2. So when we do this in the calculator, on the top you're going to get 255.75, and then I'm going to divide that by 1/2. So my answer for this one is going to be 511.5. Now when we do our infinite sum, the formula is different. So for this one, we're going to put a 1 over 1 minus r. So that's going to be 256 divided by 1 minus 1/2. So that's basically going to be 256 divided by 1/2, or 0.5, which is going to be 512. So these formulas are important, and it's important that you guys know how to do this. And let me just show you this. If you're trying to put this in the calculator, you might want to put this in another set of parentheses. It might work out a little bit better for you, okay? Just because when you do the minus, it's going to take the minus and multiply it by it. So it just depends. Go ahead and try it either way to make sure you get the right answer so you get a little practice. So number 7. So again, we're going to take the second term and we're going to divide it by the first term. So that's going to give us our common ratio is going to be 10. So when we multiply 10 times 100, we get 1,000. We multiply 1,000 times 10, we get 10,000. And then we get 100,000 for our last term. Okay? Those are our next 3 terms. Our explicit formula for the 13th term would be a to the 13. And again, this time I'm just going to put our 1 times 10, and we're going to do 13 minus 1, right? So this is going to be 1 times 10 to the 12th. This is what I'm looking for if I say the explicit formula. Now when I do that, our answer is going to be 1 trillion. So basically 1 with 12 zeros, okay? So the sum of the first 6 terms, this is a different formula now. We're going to do the sum of 6 terms. So that's going to again be our first term times 1 minus our ratio to the 6th power divided by 1 minus r. So let's go ahead and populate this formula again. So our first term was a 1 times 1 minus our ratio, which was 10 to the 6th, divided by 1 minus 10. So this is going to end up giving us on the top a negative 999,999, and this is going to give us a negative 9. So when we get our answer, it's going to be 111,101. 111,111. There we go. Okay, so that's what the sum of the first 6 terms is now. The other one is going to be s to the n, and this one again is, remember, it's going to be a1 divided by 1 minus r. So this is going to be our first term, which was 1 divided by 1 minus 10, which is really going to be what? 1 over negative 9, which would be negative 1/9, or what? 0. So this is going to be a negative, right? 111 again, okay? So this one says the first term of a geometric series is 1, so a1 equals 1. The common ratio is negative 4, and n equals 7. So it's asking us for the 7th term, so we're going to say a to the 7th is equal to 1. That's our first term. Ratio is negative 4 to the, again, 7 minus 1. So this is going to be 1 times negative 4 to the 6th, right? So that answer is 4096. And make sure you take that negative 4 and put it in parentheses when you're doing this in your calculator. And recall that when you take any number to an even power, the answer is always going to be positive. All right, so this next one says for a given geometric sequence, the common ratio r equals 6. And then this time we're given the 5th term, right? So this is a to the 5th is equal to 25,290. And then it's asking us to find a to the 10th. Well, the problem is we can't find a to the 10th if we don't know a to the 1st. Or basically, we can't find the 10th term if we don't know the 1st term, okay? So if I write how to find a to the 5th term, basically, we would do a1, right, times our ratio, which would be 5 to the 5 minus 1, right? So notice here that we do have this term, right? So we can put it here, 25,290. And then that's going to enable us to solve for a to the 1st, because this is going to be 6 to the 4th, right? So this is 25,290 equals a to the 1st times, and this was 1296. So how do we get rid of the 1296? If we were multiplying, we divide, right? So we're going to divide both sides by the 1296. So that means our first term is going to be 20. Now we can use that to solve for our 20th term, okay? So what we're going to do is we're going to solve for our 20th term, or sorry, our 10th term. Our 10th term, sorry about that. So to do that, we're going to put our first term times our ratio, which was 6th. And again, remember, we're going to do 10 minus 1 here, okay? Sorry. So that's going to be 20 times 6 to the 9th. So when we do that in our trusty little calculator, we get 201,553,920. All right, our last problem says in his first year, a math teacher earned $32,000. In each successive year, he earned a 5% raise. So our A1 is going to be what? 32,000, right? Then our ratio, most of y'all are probably thinking that the ratio is going to be 5.05, but it's not. It's going to be 1.05, because otherwise we're going to have to add the 5% to the 3,200 or 32,000 every time. So what we want to do is make it 1.05. So it says how much did he earn in years 2 through 5? So in year 2, he earned what? We're going to do the 32,000 times the 1.05, right? So on that one, it's going to be $33,600. Then what are we going to do for the next one? For year 3. Same thing, right? So we're going to take our 33,600 times our 1.05. So this one's going to be 35,280. And then we're going to do that for years 4 and for 5. Okay, so when we do that, we're going to get 37,044 here. And for our 5th year, we're going to get 38,896.20. The next part of this problem says how much did he earn in his 20th year, okay? So for that part, we're going to do a to the 20, right? The 20th year. So that's going to be our 32,000. And our ratio again is 1.05, and this time we're going to do 20 minus 1. So the way we're going to do this is 32,000 times 1.05 to the 19th, right? So this one is going to be equal to $80,862.41. So our last one is what were his total earnings. So this is going to be the sum of 20 years worth of earnings, right? So this one's going to be, again, our A1 and 1 minus the 1.05, and this time it's going to be to the 20th power, and this is then going to be divided by 1 minus 1.05. So when we do this, what we get on the top is negative 52905.52656, and then we're going to divide that by what? A negative 0.05, right? So our ultimate answer for our total sum of our compensation over 20 years is going to be $1,058,110.53. And I think my key said 58 cents because I couldn't read my own handwriting. So hopefully this helps you guys. Good luck on the test, and make sure you guys turn in all the Unit 12 homework assignments by 11:59 tonight.